Covalent bonds are formed when electrons are shared between atoms. However, not all covalent bonds are the same. Sometimes the electrons are shared equally, such as an iodine, and sometimes the electrons are closer to the more electronegative atom, such as water. In a nonpolar covalent bond, the electrons are shared equally or have an electronegativity difference of 0.4 or less. If we look at this chart, bromine has an electronegativity value of 2.8. So you do 2.8 minus 2.8, and that's a difference of 0. So bromine must have a nonpolar covalent bond. In methane, the electrons are being shared between carbon and hydrogen. So carbon has an electronegativity value of 2.5 and hydrogen a 2.1. That's a difference of 0.4, so it's nonpolar. In a polar covalent bond, the electrons are shared, but with an electronegativity difference of more than 0.4. So if we are looking at HF, fluorine has an electronegativity of 4, and hydrogen has an electronegativity of 2.1, so that's a difference of 1.9. So that's a polar covalent bond. To indicate the polarity of a bond, first draw an arrow over the bond pointing to the element which is more electronegative. This shows that the electrons are attracted to that element. So in this compound, we would draw the arrow pointing towards, if you guessed fluorine, you are correct, because again, we want it to point towards the more electronegative element. If you put a tail on your arrow, then it'll help you on the next step. Assign slightly positive and slightly negative signs to each element. The element that's more electronegative will be slightly negative, while the other element will be slightly positive, since the electrons are now no longer close to that element. So if you put a tail on your arrow, you can see it looks like a plus sign, and so that's where your slightly positive sign goes, which is kind of like an S with the tail pulled up. So go ahead and pause the video and answer these 4 questions. You should have gotten that the total number of bonds in water is 2. Of those, they're both between hydrogen and oxygen, which have an electronegativity difference of 1.4, so there are 2 polar and no nonpolar bonds. And if you draw water showing the polarity, the arrow should be pointing towards the oxygen. With your oxygen being slightly negative and hydrogen being slightly positive. Go ahead and order the following bonds according to polarity. So you need to find the difference in electronegativity for each of these and then rank them. So looking at the periodic table, you need to know that fluorine's a 4, oxygen is a 3.5, so notice it goes down by 0.5, nitrogen is a 3, carbon is a 2.5, and boron's a 2. So you can memorize those values. And then while going down the periodic table, fluorine's a 4, so chlorine's a 3, So it goes down by almost 1 whole. So silicon is technically 1.8, but we can just assume it to be 1.5. So we can guesstimate. So hydrogen, because it's nonpolar and it's sharing between itself, it's going to be the lowest or the least polar. And now we need to look at our differences. Oxygen, hydrogen was a 1.4 difference. Chlorine, hydrogen, a 0.9. Sulfur, hydrogen, a 0.4. And a fluorine, hydrogen, a 1.9. So sulfur, hydrogen, and then chlorine, hydrogen, then oxygen, hydrogen, and then fluorine, hydrogen. And since all these had hydrogen, you also could ignore the hydrogen and just rank them in order of electronegativity. I'm going to pause the video and try this one on your own. You should have gotten A as the correct answer. B and C we can eliminate because we know that HF has to be the most polar. And then looking at your chart, you can see that carbon is more electronegative than selenium.